Hey everybody, it's Dr. Phil from medpathway.com. We're going to look at the skinny on thin layer chromatography. So the question that we had is that you want to separate thymine from uracil using thin layer chromatography. What you see at the bottom there is a typical result of a thin layer chromatography experiment where you're separating two molecules A and B from its origin. And so how does TLC even work? Well, what you have is a cellulose plate or a relatively hydrophilic surface where you spot your mixture at the origin. After you dry it, you take it and you put it into a solution that's more hydrophobic, such as butanol. And what's going to happen is that by capillary action, the butanol is going to move up the plate, and those molecules that are more soluble in the butanol, that is those that are less polar or more hydrophobic, are going to move up with the solvent front, but more polar molecules that associate with the plate and will not associate with the butanol will tend to stay lower on the actual thin layer plate. So polar is lower and more slower is one of the slogans of TLC. So what about thymine and uracil? Well, you remember that thymine has that extra methyl group, and that's the key distinction between the two molecules. Therefore, that methyl group is hydrophobic, and you could expect that thymine is going to be molecule B. One other thing that people often talk about with respect to thin layer chromatography is a value called RF, which means ratio to front. And that is basically the distance traveled by the compound divided by the distance traveled by the solvent. And so therefore, less polar molecules will have higher RF values, and that's something you should definitely commit to memory for the MCAT. Come check us out, medpathway.com.